Benjamin Bois is Associate Professor of the University of Burgundy in Dijon. University of Burgundy is also a partner of IVES OENO 1. So Benjamin was graduated from Bordeaux Sciences Agro in 2002. He also has a practical experience because from 2002 to 2004, he worked as a winemaker in the Bordeaux area, but then he got caught by the research virus, and he engaged in a PhD working on the climatic diversity of the Bordeaux area, and he's ever since been doing research on climatology. So the consequences of climate variability in viticulture, so the climate spatial structure at various scales is one of his research topic, water availability at local scale, and also climate evolution in viticulture. So the approach of Benjamin is he's using multivariate modeling approaches and also geostatistics, but also doing a lot of field measurements of climatic parameters. So Benjamin is going to give us a talk about the zoning of the climatic potentialities and the risk of vineyards and wine production regions. So Benjamin, very happy to have you here at this IVES OENO 1 Science meeting, and the floor is yours.
Well, thank you, Case, and hi, everyone. I'm Benjamin Bois, and I work at the University of Burgundy at the Climate Research Center, and I am part of the IVES, which is a member of academic member of IVES. I'm going to talk about you today about climate, the interest of zoning climate potentialities and risks for wine production. But first, I would like to recall a few things about zoning. Zoning consists in dividing space into areas with homogeneous features, or areas for which you can apply, even if they are a little bit different, within the area, you can apply the same kind of application, agronomic practices, for instance. I will give, for example, the case of the soil map. A soil map can be considered as a zoning because soil, as you know, is not discontinuous in space, as you can see in this map. Soil, indeed, is the result of different parameters, such as gravel content, acidity, and depth, and so on. So here you got a soil map with 6 different types of soils, and each type of soils has features that are similar, but they are not identical in all the parts of the space of the soil. And so this is zoning, and from this kind of map, you can also provide other zoning, for instance, a zoning of rootstocks adapted to the soil features, soil management activities, or also winemaking adapted to winemaking itineraries, adapted to the kind of soil you have. I'm talking about soil here, but my presentation is, of course, about climate. Why I use soil? Because soil maps are very popular and used a lot in vineyards by grape growers and winemakers, and the use of climate zoning is a little less frequent, but it's quite old. In the 1944, for instance, there was a zoning proposed by Amarin and Winkler for California. You know probably this zoning. It divides California into 5 different regions, and each region has a specific feature based upon the heat summation, the famous Winkler index. And Amarin and Winkler provided a very long monography with varieties and wine style adapted to each kind of zone that were provided. But the interest of climate zoning for viticulture is much larger. You can do a climate zoning for identifying which part of the land is suitable for viticulture, And if you want to identify terroir or delineate appellation, you can also use climate zoning. As I just shown before, climate zoning is useful to assess grapevine adaptation based on earliness, based on degree days, and adapted phenology to climate conditions. You can also use climate zoning to identify which part of the areas are of specific water characteristics, water functioning characteristic for the plant. You can also, and this is a very important use of climate zoning, identifying related risks such as pest, disease, frost, extreme heat, or winter cold. And also use climate zoning for communication and marketing. A lot of areas, vineyards or appellation use climate maps to identify to the variability they have and the specificities of each of their terroirs. So now I will recall the different steps that you need to follow to perform the climate zoning. It's not exclusive. You can have perhaps different steps, but this is a general framework. First, you need to identify the climatic context. That is the general monthly feature. If the area you're looking forward to perform the zoning to as frost risk, heat risk, water deficit, it's warm, it's cold, late, early, and so on. Then you need to assess the spatial variability of climate. You can use different information such as land cover, terrain, soil maps, remote sensing, and of course, measurement of climate variability at local or mesoscale. With all this information, you can provide climate maps. But if you want to perform a zoning, you got to identify which of these areas have similar climate features. That's how you will provide zoning, for instance, of earliness, potential earliness based on its emission, for instance, its stress of frost, and so on. And then you can make decision. Pick the right cultivar to adapt it to each zone. Identify if you need to have a specific device to adapt to each stress or frost. So I will go in detail. First, concerning the climatic context, you can do this very easily now. If you look on the internet, for example, you can go to the climatedata.org, where I found this graph. This is a monthly rainfall and temperature value in the Mendoza area. And you can compare it to other areas, for instance, Adelaide climate. So very easily you can compare, identify which part of the year is more rainy, is drier, and so on. If you want to go a little bit further and do spatial analysis, you can use a WorldClim data set. WorldClim data is very interesting because you get 1 kilometer resolution all over the planet, but these are averages on 30 years of monthly temperature, precipitation, and evapotranspiration. Similar data can be found by the Climate Research Unit, and also you get models reanalysis from NOAA or European Climate Center. They all provide monthly data or daily data at 30 to 50 kilometer resolution. And if you're not very familiar with specialized data, you can also use daily data, daily climate data from station, and you get two very interesting database, the ECAD for Europe, and also the Global Historical Climatology Network, which provides you in an open access manner with 100,000 stations worldwide. And also you can browse on scientific articles such as on IVES platform. And I'm thinking specifically about the Terroir Congress proceedings that you will find on the Hive Concern Series website, where you will find high-resolution climate spatial analysis data comparison. This is an example of a work we've performed for Europe. attributing different giving different type of cluster for each wine regions of Europe, so you can find homologies to climate condition and compare and characterize the climate condition of your region in comparison to other. Second step is to assess the spatial variability, and for this you might find very useful terrain data, such as digital terrain model. So this is a map, a digital map of elevation of all over an area. This is, for instance, Marsanne-la-Côte in Burgundy, in Côte de Nuit. And to manage this data, you can use GIS software, geographical information software. This very popular is QGIS, but you can also, I use a lot SagaGIS, which is very popular to manage terrain data. And you can provide with this kind of software a potential incoming solar radiation map to identify area where you will get a lot of evapotranspiration or heat stress, and also topographic wetness index, which simulates the cold air drainage on an area. I'll give you an example. Here this is a map in red. You got the areas damaged by the 2009 frost event that we had in Burgundy, in Côte de Nuit specifically. About 40 hectares were damaged. And if you simulate the airflow based on terrain information, there is no climate measurement here, you will find that all the damaged area are on flow lines, simulated flow lines of water, but we use it for to simulate the flow of cold air, and which has been blocked by the road. This is the line that you see here. I show you a picture there. This is an aerial picture of an area damaged, and the airflow that coming from the hill downhill was blocked by the road here. So you can simulate this with terrain data. But of course, it's very interesting to validate this with climate data measurement. And now climate sensors are very cheap, and there are plenty of them. So it's very easy to install a lot of sensor in the vineyard. Plus, you got some new communication device such as Sigfox or LoRa, which is very cheap, much cheaper than your smartphone that you need to pay every month a lot of dollars, euros. Sigfox and LoRa are very cheap communication systems and can provide you with instant data on your smartphone. An example of the interest of measuring climate on a plot, this is a 2 hectares plot, and we installed a lot of temperature sensor here, and we measured frequently difference of 2 degrees in minimum temperature. This is an area where you find a lot of frost. It's in Burgundy again, and we get and you can find 2 degrees with only 6 meter difference in elevation from 2 different plots, different area in the plot. So once you've measured and analyze climate variability, you can provide climate maps. You can produce climate maps. For instance, this is a map of minimum temperature in Bordeaux wine producing regions. And in this map, you can see that even if Bordeaux region is not very hilly, is rather flat, for example, like in Médoc, you can find a lot of diversity in minimum temperature. This is the minimum temperature on the growing season. It's an average from 2001 to 2005. So you can see that you have a very large diversity, even if the terrain is not very strong. And Laure de Resquier and Al, some colleagues from Bordeaux, studied the Saint-Émilion area and also identified 3 degrees at local scale. So you see that according to the scale level, you can find a strong diversity, a different type of scales. Once you've produced those maps, you have to analyze zones that have similar features, which is a zoning, and make some decisions. Again, the climate of Bordeaux wine producing region, using a degree days model, we produced this map simulating the earliness of harvest, the potential maturity, ripeness of grapevine. And we identified 5 classes from very early to very late, and also areas that were not classified, but because some vintage they were early, some vintage they were late, but it's a very small part of the whole area, in fact. And what you can see that in early areas such as Saint-Julien, Saint-Estèphe, or Margaux, or Pessac-Léognan and Saint-Émilion, you can promote planting of later cultivar because it's warmer, and also a specific warning concerning climate change. And on cooler areas, you will need to plant early cultivars such as Merlot and white varieties. So to conclude with this presentation, we've seen that there are many applications of zoning in viticulture, such as assessing frost risk, earliness, or water availability. That this is made possible now to have to do zoning as a very on very small area with at a very fine scale, because we have now plenty of data that is available. There was improvement in spatial sciences and software available, and devices and communication system are very efficient and not very expensive. But just before I finish my presentation, I would like to make a small warning concerning 2 things. First, beware of the very nice maps with nice color, very high resolution, because high resolution do not mean precision. You need to know what is the quality of the map, the precision, because sometimes there are very nice maps, but that don't make any sense because the precision of the map is not good. And also, when you use model remote sensing to produce those very nice maps, it's always useful to do validation in the field using climate measurement or plant measurement. Well, I'm done, and thank you for your attention, and thank you for organizing this very, very nice meeting. Looking forward to see you in the next future.
Okay, well, thank you, Benjamin, for this very nice and interesting presentation. So I know you did groundbreaking research by showing that when you combine climate measurements made in weather station with topographic data, you can increase the resolution of the maps that you that you produce. So then we can come to a question about, well, we know that in viticulture, hillside locations are very often high quality locations. It's not easy to separate the effect from the soil and the effect for the climate. But as a climatologist, do you think that the hillside effect promoting wine quality is more a climate effect or more a soil effect, or a little bit of both? You need to unmute your mic.
Yeah, is it okay? You hear me? we got a few. You got a few practical examples here in Burgundy, because you know, soil type, subsoil is quite heterogeneous here in Burgundy, but in some hill slope, you can have some very specific terroirs and Grand Cru that are located there, and soil seems homogeneous when you compare it to a close by plot. But even on this plot with many different grape growers, you will find always in this cru, premier cru or grand cru, a good quality is coming from this plot. And the topographical position is always mid slope, and it can explain in sometimes the quality of the vine more than the soil. But you got the answer in your question. It's always a matter of combination between climate and soil, and it's you can distinguish what are the role of each one of them, but you need to do a map. You need to do measurement to see the contribution of those, because without this you don't know.
Okay, so there are many questions from the audience. There's a question from Damien Martin from New Zealand. do you have any models that might separate vigor effects on phenology from topoclimate effects?
Yeah, do we have any model that separates vigor from climate?
Effects?
Okay, when you go to when you go toward validation, this again needs to be measured on the field. You can discriminate the effect from the plant material, from the fruit that is linked to climate. I think Damien is thinking about perhaps the earliness of the grapes that might be also affected by different crop effect, cultivar, and the vigor we observed. What I can say is when we worked on Bordeaux area, and also again in Burgundy we did a similar work. We tried to validate our climate zoning using observation in the field on different plots, and for sure those plots had slightly different soil features, and even if it was the same cultivar, the clone was different, the grape grower was different, and we've still seen a strong link between phenology observed and climate conditions. So that was something we didn't expect that much, because trying to validate interpolated climate data with fields with so many different features, we said it's gonna we don't have a strong signal. But for flowering, for veraison, we had a good correlation with the map. So it all depends on the intensity of climate difference you get on the area. If you get slight difference, then the plant characteristic will go over. I'm talking about phenology there, earliness there. But if the climate difference are large, and sometimes they can be very large, even on a few hundred of meters, then you will see the signal from the climate.
Yeah, that's also what we observe when we do phenology modeling, that you can pretty well explain phenology by temperature only. So temperature is definitely a very strong driver of phenology. There's a question from Cassandra Collins about the application of your research. So if you work with growers, what are the most straightforward possible applications for growers from your very refined climate mapping in vineyards?
Okay, but currently we're working a lot for. I will say a few of them. I'm still convinced that when you first concerning planting a new vineyard, I'm still convinced that the first thing you need to have is a soil map, a good soil map. But then, in second, if you got a little bit of topography, it's very interesting to have a climate map, and specifically temperature, because it helps a lot in picking the right clone and cultivar according to the area. So this is one application. Another popular application, specifically because in France we had a strong frost events in 2016 here in Burgundy, 17 in whole Northern Europe, and 19 again. So frost is becoming a big issue in France. I know also in Bordeaux, and so we're working in refining climate zones where you can to pick the right device or the right mode to assess frost risk. And at a much broader scale, we've been also working on characterizing climates from all over the world, like in 600 more than 600 different regions worldwide. And we had a project with grape growers from Burgundy. We wanted to plant some vines in Hokkaido in northern Japan, and so we helped him by comparing the climate condition of Hokkaido to other regions worldwide, and we've seen some similar feature to Finger Lakes. So those are also at a larger scale application that we can do for useful for grape growers also, I think.
There's a very general question from Pierre-Louis Tesser. Is zoning the future for viticulture?
Is zoning the future for
viticulture?
I don't know if the future, because zoning perhaps is thinking, because zones are specifically for climate, they might move with climate change, but that's true that we are having since the last 20 years having climate information and also soil information is way cheaper every day, and we got very high precision. So now you got trailers that can be guided with GPS or GNSS, so they can be precisely go in the field and spraying adapted to zones and etc. So yeah, using maps, using precision viticulture is helpful, but first you need to estimate the feature of your environment because before you make decisions. So it's somehow a very useful tool, in my opinion, for now that we know how to guide and to do intervention, apply some specific agronomic issues at a very fine scale.
Okay, there's a question from Eduardo Costantini, but maybe Eduardo needs to specify a little bit more his question. So the question is about modeling cold and heat currents in time besides space. So most of your modeling is in space, but can you also model in time?
Yeah, this is an issue, and I can share. I can understand why Eduardo is asking the question. You know, when you're trying to map minimum temperature, which is very interesting when you want to manage frost events, modeling airflow only using terrain analysis. You can do that on a very old map as well, but it's more refined with digital software and so on. You will see that there is this typical cold air drainage that go on a specific spot. But when you do the measurement of minimum temperature at the daily time step, you don't have the minimum at different spot at the same time. And the best is to work at an hourly time step. So you need, and we get the device to do that. So that's the first point. Within a frost night, for instance, or if you're looking at heat waves problems, you need it can be useful to work at a hourly time step, and then you need to think that you can't be satisfied only with that and only with one measurement of one event, because depending on the wind, depending on the climate feature, your zoning might move a little bit. So you need to have several measurements to get the information. So yeah, you need to integrate space and time.
Okay. Thank you. There's a question from Eric Kohler. Do you connect your climate zoning with the risk of fungal diseases? Is there any use of your modeling to do a zoning for diseases, in particular fungus?
Well, in fact, there is little research of this. You know, a lot of consultants and researcher and research development structures use models, fungal models, based only on mostly on climate data, But they're talking about places where there is a historical problem with mildew, downy mildew, powdery mildew. But those in those spots, we tried to look during the last 3 years with Sébastien Zito, a PhD student. We compared 6 different plots, and some were known to have a high mildew pressure, and we measured relative humidity, leaf wetness duration, temperature in the canopy and inside the plot to see if there was link with climate condition. We didn't publish this data yet, but only at a conference. But what we've seen is the explanation of the pressure of powdery mildew was perhaps more related to the earliness of the plots, which is an explanation, but that's not satisfied me, because I thought that
direct effect
could help,
because temperature influences phenology, and then phenology influences the susceptibility to diseases. There's a question from Mark Brevo from Moore, Tennessee. Can you make climatic zoning in real time?
Yes. You need to have a communication device that I was talking before about, like LoRa and Sigfox, And yes, you can do automatic interpolation, and it's even more relevant to work at a instantaneous time step, because the maps you get are more specifically for temperature, are more in line with what happens physically, because you got an air mass with characteristics that moves, and you can capture this at a instantaneous time step. Yeah.
Okay, thank you very much, Benjamin. I keep an eye on the timing. We're perfectly on schedule, and I think it's now good to put an end to this session. So we'll give a warm round of applause to Benjamin for these very, very nice explanations.